ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your moderator for today's event, in which we're going to talk about some really, really exciting stuff, folks. We have an all-star cast for you. Here's a slide about yours truly and enough about me. As many of you know, the mission of the briefing room is to reveal the essential characteristics of enterprise software. It's not the easiest thing in the world if you're out there trying to buy some new enterprise technology. And as we all know, usually this stuff is not terribly inexpensive, so you sure want to make sure you get the right technology to suit your needs. So what we do is we pair vendors with independent analysts, and we expose a live, unscripted analyst briefing for the benefit of a virtual studio audience. I will tell you that your questions often make this a really educational and interesting and frankly entertaining event. So I'm sure you won't be shy, but just in case, don't be shy. Ask any question you want. We'll get to that in the Q&A component of the webcast. So the topic of today, the topic of this month, is analytics. The specific topic of today is the changing face of analytics and how to stay ahead. We cover a different topic each month to help you get apples-to-apples comparisons across different domains and different disciplines to help you make a decision of what to buy, of what is going to fit into your particular set of needs and budget, of course. So, you know, analytics, we were talking about this just the other day. My partner, Dr. Robin Bloor, and I were talking about the evolution of analytics, and there is some amazing stuff happening these days. Of course, we all have this recollection of where data warehousing and BI began, the people in this industry, and it's certainly been evolving, a lot of innovation going on over there. But in the last couple of years, last 2 to 3 to 4 years, I suppose, there has been an absolute wave of innovation in the analytics space. And frankly, there are all kinds of ways you can get things done now. If you look at the amount of change in the database market alone, it's downright bewildering. You have all these interesting database options these days, and I've heard just about every analyst I know comment that they were really quite surprised at the number of new and innovative companies stepping into the database space. You have graph databases, you have algebraic databases, of course all this NoSQL stuff we're hearing about. Not only SQL is what it usually means. We actually did a whole report on the database revolution. You can find a website, databaserevolution.com, which talks about that. And as I was thinking about all of these changes, and of course we have Hadoop out there and big data and this whole ecosystem that's building around that Hadoop offering, which is not exactly in this whole BI DW space. It seems to be growing up alongside. Companies like SAP and Teradata and others are trying to sort of weave it all together. We had IBM in the briefing room a few weeks ago talking about their big data platform. And goodness gracious, it is downright amazing how much stuff is happening out there. So today, to kind of kick us off, just for a couple of minutes, I wanted to bring in our own Dr. Robin Bloor to talk about something that kind of sparked out of our research last year and this year, and I'm going to push one of the slides that he has talked about before, but it seems to me that it's really quite appropriate for our topic today and for what we see happening, and frankly, for why we're looking at something called the event-driven architecture for our next research project. So, Robin, can you want to comment just on what you see happening out there and how it applies to this slide?
Yeah, sure. Well, I mean, let's go off the slide. I've presented this slide a number of times, and if I present it in all of its full detail, then what we're going to get here is a long lot of words. But really, if you just look at the leading curve on this, what this is showing us that is as time goes forward, the latencies fall for all workload sizes, basically. And in the last since about 1990, we've moved into real time, which means faster than 1/10 of a second, technically speaking, because human beings require 1/10 of a second to respond to anything. And what's actually happening is that the area of real-time activity is getting bigger and bigger and bigger. And what this is enabling, and the reason why you and I were talking about the event-driven world, is it's enabling systems to be built that fly off events rather than transactions. So, you know, around, I mean, if you just think of a purchase on Amazon, then, you know, it involves an awful lot of moving from page to page to page before anyone actually buys something, which is a traditional transaction. And an awful lot of business processes can be broken down into events. But when you do that, you then have the possibility of streaming the analytics at the same time as you're capturing the information. So the analytics starts to move to potentially real time. I mean, you know, analytics on big heaps of data is never going to go real time, but that's getting faster and faster as well. And my feeling, and we'll investigate this more and more as the year goes by, but my feeling is really that the whole architecture, if you like, you could say we're living in a service-oriented architecture world, plus, I guess, the information-oriented architecture that we talked about last year. But, you know, those define the way that architecture runs, and now I think it will be driven by an architecture based around events. And that will be quite different, and I can't go into any further depth, but at this point in time, we're actually still just gathering information, as you're well aware, Eric.
Yeah, yes, indeed. I did feel like what we're talking about today really speaks right to the heart of that whole transformation, which is why I wanted to talk about this. So let's go ahead and move on, and then we'll maybe talk about that more in the Q&A session, and we'll have other events coming up as well to talk about it. So I just wanted to tip you off to all that. Our analyst today is Rick Sherman. He is a veteran of the briefing room. Very happy to have him on board. And Actian, so formerly Ingress. Actian is a database and software development company. Perhaps you've heard about Vectorwise. It is a performant analytic engine that implements parallelism at every level, from the processor core to data storage. So we're going to talk about vector processing a bit today, which frankly I find quite fascinating. So let me go ahead and push this next slide. Here's Fred Gallagher. He's the GM of Vectorwise. And there is your first slide. I'm going to go ahead and hand the keys over to you guys over at Actian. And there you go. The floor is yours.
Hey, thanks a lot, Eric, and thanks a lot, Robin. Appreciated that. So again, Fred Gallagher here from Vectorwise at Actian. Let me just enhance Eric's description of Actian today. So today, Actian, we're a data management company. We provide data infrastructure to a number of enterprises around the world. We own the Ingress database, which some of you may be familiar with. We have over 10,000 customer deployments worldwide, and some of those deployments are not just in mission-critical scenarios, but also what I call business-critical implementations, whereas the company really runs on Ingress. We also provide Vectorwise to the market, which I call the world's fastest analytical database. And we also have a new category of products that we call action apps, which are connecting insight from analytics to action. And we'll talk a little bit about that as well. So let me set up the, sort of how we look at some of the opportunities around data. And there's been quite a bit of research and quite a bit of ink has been spilt on this topic in the last couple of years. So let me just cover a couple of these. I mean, I always like to put this slide up because it provokes some thoughts. If you look at the amount of data that enterprises use today, it's actually less than 5% of their data is used for analytics. And sort of a what-if statement, what if we could double that, triple it, or quadruple that? What would the implications be? There was another research that was done, published last year by McKinsey, that analyzed the economic benefit in a number of different industries, and there's a number of other analysts that, including Flora Group, that have looked at this. And when have you had so many brand name organizations identify such a big opportunity is really the point I try to make with these slides. So many of you in the audience have probably already heard of that. So one of the things that I like to talk to is really where does the rubber meet the road? What is it like from a real world perspective in terms of taking advantage of the opportunity? How do people do that? How do companies do that? And so some of what I call the data management challenges, and to use the name of the day, the big data management challenges are varied. When we at Actian are engaging with prospects and existing customers, typically they'll have an environment that's varied. So you'll have many databases that are distributed around an organization, and sometimes we use the word data silos. And what we mean by that is the data is tied to an application. And the reason that's happened is over time, a company has grown. They've brought more and more transactional applications in-house, and the data underneath those is really the data model, and the database was built for that application. And to go back to something that Dr. Robin Bloor highlighted is many of those applications were not designed and developed with an appreciation for where we were moving in terms of this real-time world. They weren't designed for the 21st century. So companies had to implement something 10, 15 years ago. The other thing that we see when it comes to data infrastructure is when companies sort of face a dilemma, in my opinion, when it comes to the expense or the cost of data infrastructure. Specifically, what I mean by that is sometimes the infrastructure is fairly large that needs to be deployed, and so there's a fairly significant upfront cost associated with that. Or in other instances, if someone tries to start with traditional relational technology, a lot of cost comes in later when they try to when that organization tries to scale that technology, and I guess I would assert that it really fundamentally doesn't scale. Another point that's key, especially in 2012, are additional data types. In the bottom left-hand corner of this slide, what you see in organizations when I'm engaging in organizations, not only do you see, hey, I have a number of existing or maybe even legacy applications. We're being flooded by other data, be it from a SaaS application, be it from a Twitter feed, be it from some social media source, and there's other data that comes in as well with some of our customers that is it's log data, machine data. So organizations are just flooded with data, and I think you'll see that with most companies. So the other sort of thing that's weighing into these two phenomena, legacy applications and a flood of new data types, are user requirements. And my opinion is that we today are actually less patient with technology because of the advances that have been brought about. And again, go back to Robin's slide and the Bloor Group's slide on real time. Today we have devices, I have an iPhone here, that it is very much a real time. It's very interactive, it's very engaging. I have a single app that will be open and the answers come back in just a matter of a few seconds, whereas 10 years ago, 15 years ago, folks were using desktop technology where data searches, data queries would come back in minutes, maybe best case 10 to 20 seconds. That was the ideal. And so as technology has moved forward and become more real-time, users are more demanding. The other thing is when I'm engaging with our customers, the customers are asking more advanced questions of the data. The users have become more knowledgeable about asking those questions, and so that's another requirement that we see in the market as well, and there's more of them. And so user concurrency starts to creep into the discussion as well. And again, it ties to this concept. We'll use the word real time, but I always like to use the word business time as well, because I think really the need for many organizations is that they want to bring data to help them solve a business problem at a given time wherever they might be. And so that's really some of the needs that we've seen in the marketplace. And really what companies are trying to achieve, here's a slide that I've taken a liking to, is really connect events that are taking place in your organization, and it could be changes in data, or it could actually be sort of a stricter definition of events, and move that analysis and create a tighter linkage to actions that need to be taken in the business. And what do I mean by that? If I look at organizations capture data in their transactional systems, on their websites, maybe on logs and machine, and that data is available to be analyzed, and there may be some corresponding actions that folks want to take in that. There's a technical discussion that's associated with the technology to achieve that connection between events and actions. There's also a business process. Many organizations, there's business processes that are prohibiting the movement of data or analysis of events along that flow. So both of them actually need to be analyzed. And so this is really what we're trying to achieve, because if we can shrink that time, it provides greater value to an organization. We'll speak to some specific context, because I think that helps. And so in that vein, this is where we've brought the Vectorwise product to market. We first introduced it, Vectorwise, 2 years ago, and it is really a breakthrough technology. And here's a proof point, a few proof points actually, around Vectorwise in terms of addressing this need for performance and shrinking the latency in organizations. And what this is a graph of an industry standard benchmark known as the TPC, for Transaction Processing Council. The test is known as TPC-H. And what this is on the top axis, I'll refer to that as the x-axis, is that's a metric that's called the QPHH. Think of it as miles per hour. It is how fast does a specific database run a defined set of queries on 1 terabyte of data. And you can see here in June of this year and May of last year, Vectorwise has put up numbers that are well ahead, not just well ahead, they're just sort of, a leap ahead of the market. You have a variety of other databases that you may have heard of from other vendors, and they're, best case half of what Vectorwise is. And I think the stunning thing inside of this is really that leap forward, because you can see there's sort of a natural progression at a much smaller slope of those bars than what Vectorwise achieved in terms of its leap forward. And if I go to the next slide, here's the other point that I'd like to make to folks about sort of the affordability and actually the scalability of the technology. If we're to look at the hardware cost, the server and storage required to achieve each one of those benchmark numbers, we've put that on the right-hand side of the chart here. And you can see for the benchmark this past June, the hardware cost was $57,000 for the Vectorwise benchmark. And if you go down starting on the non-Vectorwise numbers, you start to see numbers that are $400,000, $2 million, $700,000. So the point is, for a fraction of the hardware cost, we've delivered this leap forward in performance, and it really shows that we provide an affordable level of performance. And so how do we do that? So let's spend a little bit of time talking about how we're different and how Vectorwise is unique. And let me spend most of the time on the left-hand side of this chart of the Vectorwise technology, items number 1 and 2. The fundamental difference with Vectorwise is that we're taking advantage of vector processing and vector registers. And this technical capability has been around for years, actually, and it's resident in it's resident in all modern chips, Intel and AMD, and even some of the RISC Unix chips have vector registers. Actually, never mind some, it's all. So it's a very broadly available technology. And what vector processing allows is we're able to operate on more data at once than folks that don't use vector processing. And the opposite of vector processing is actually scalar processing. So we take advantage of this capability that is been invested by folks such as Intel and AMD for years, and it required a rewrite of our query execution engine to take advantage of this capability. The other aspect that we have is it's referred to the slide as on-chip computing, and what that explicitly means is that we have algorithms that allow us to move a compressed vector of data from disk to memory to the L3 or L2 cache on a chip. And so that was necessary to sort of, once we have unlocked the power of vector processing on the chip, is to feed the data as quickly as we can to the chip. And so what we're able to achieve, if we take it down to a single core on a computer, at a base level, we're achieving data processing rates that are north of 2 gigabytes per second per core. And when we unlock that capability, it's very important to feed that sort of processing machine as quickly as we can. And so for that reason, we utilize these other two technologies that are on the chart, the column store as well as compression, because a compressed column store is a very streamlined convention to move data from disk to memory, and then we move that as well onto the L2, L3 cache. And then finally, we've also taken advantage of parallelism across multiple cores, in that we're able to parallelize our queries across cores and take advantage of the multiple cores that Intel, AMD, and hardware vendors are delivering to the market. So it's a number of innovations that we're using, but the primary ones are these concepts around vector processing, which allow much more data to be deployed on the chip in the registers and actually inside of the pipelines and hyper pipelines that exist in most modern processors. So very much a technical deep dive. If there's questions on it, please come forward. But I think what I wanted to speak to now is really how are customers benefiting from this technology that we've delivered to market. And a few examples here is Sheetz Inc. is a convenience store. Actually, it's a quick service restaurant and a convenience store in one. They're based on the east coast of the United States, anywhere from Pittsburgh down to Raleigh. They have well over 400 stores, and they had a data center very much like the example I had a few slides back of a number of transactional applications. They're being flooded by data types, and users are putting more demands on the IT or the data team at Sheetz. And they did an analysis of Vectorwise, and they were analyzing, they had a need for their point of sale transactions to do daily analysis of products that were moving in stores. And they really needed a new platform that would help them grow for the next 3 years, because they're on a fairly healthy growth rate, adding 30 stores a year. And so after analyzing a few products on the market, they selected Vectorwise for both the performance and the affordability, and the fact that we allow them to analyze more data, and they're expanding their use of Vectorwise in the organization. Another interesting one is Zoho, which is a SaaS provider of a few different offerings that help companies be more productive, sort of online productivity, and as well as CRM. And they had a requirement for Zoho Reports, which is used by over 200,000 of their customers. And so they went through a thorough analysis of products on the market and chose us for a similar reason. Finally, one other item I wanted to mention is really sort of what we've seen in the last few years in the introduction of unstructured data and companies requiring the ability to analyze their unstructured data. And many folks think of Hadoop when they think of unstructured data. We've experienced this in the market, and we announced just earlier this month our first connector to Hadoop, and we'll be staging and evolving our Hadoop connectivity as we move forward. And really what we're seeing here are folks that have very large data sets. So in this example, we have a customer, NK, which is a social network in Eastern Europe, with well over 10 million users, and they have 250 terabytes of unstructured data, where they perform a MapReduce job to shrink that down to about 5 terabytes of data that they analyze in Vectorwise in a more of a real-time interactive capability. And this is what we intend to deliver with our Hadoop connectors, that ability to expand beyond just structured data, which I think the things I see with many customers is that need for additional data types in terms of analysis. And then finally, one other customer that has a similar disposition in that they have many terabytes of unstructured data that they analyze in Vectorwise, and that's Badoo, and they have over 150 million network members. And it's really important to them that they're able to analyze offerings that they make to their social network and then how those convert. So it's very, analytics is becoming, and real-time analytics is becoming important in retailers, e-tailers, and companies that have a social networking nature to them, in that folks need to analyze on a real-time basis what are effective campaigns and promotions. So with that, maybe just in summary, and we can turn to Rick in the audience for some questions, is what we see is successful businesses today, businesses that are growing, either they're new, such as a social media company, or well-established, such as a company like Sheetz that's been around for more than 50 years. They require this interactive real-time speed and agility in their analytics. And it's a requirement that's come on. It's not just, it's new. If you go back to the chart that Eric and Robin showed at the beginning, this has been coming for years, but there's been sort of legacy applications that are placed that need to be addressed. And so BI solutions and data infrastructure solutions need to address all of these requirements. And I put down just a couple of sort of recommendations when we're engaging with customers, because it's really important to us that when we're engaging with a prospect or customer, we're doing it for them to be successful, because that begets our success. And when we see projects that have really strong alignment between the business goals and the IT goals, it sounds like a lot of mom and apple pie, but it's really important that you see that connection of the goals in the organization. And then also the other concept, which I just touched on, is connecting all the operational business processes as well as the IT processes. If you just look at the technology, you're probably only looking at a third of the ingredients that are required to have a successful project. And then I think the key point I would also make is, Vectorwise is very easy to conduct a proof of concept on, and I think we've done a good job in terms of being able to demonstrate our affordable performance and scalability right out of the box. So with that, if you're interested, please go to our website and can take a look at Vectorwise. So with that, maybe I'll turn it back over to Rick and Eric.
Yeah, I'm going to go ahead and hand the keys over to Rick Sherman. Rick, you should now have the floor. Go for it.
All right, thanks. I don't want to watch my picture too much. All right, thanks. Interesting, Fred. Just as an aside, I used to be in the database group a long time ago, so the idea of columnar approach, compression, vectors is pretty exciting to me. But let's step back a little bit and see why I think the world of analytics is changing and data itself. Just to put a couple things in context. First off, data is certainly exploding, and you see the volume, velocity, and variety. 3V's brought in a lot about big data, but whether you're using social media or not, companies of all sizes are getting increasing volumes of data. They're trying to get the data quicker. May not be real time, but they certainly need to get the data quicker. And certainly business folks need to get and do analysis, maybe not real time, but they need not only the data quicker, but they also need to be able to perform their analysis quicker, so they can't be in a queue for a large amount of time. And certainly there's a lot of more variety of data. And again, it's not just unstructured data, but people are getting data from cloud applications like Salesforce.com and Concur, et cetera. They're getting data from the various desktops, from spreadsheets, and from other applications besides their back-end ERP systems. So there's an awful lot of data coming in into the equation. And that's in the back end. And on the front end, analytics has certainly expanded. Along with Robin's picture before about data and events, on the BI side, we started off with the old standard pre-built reports. We got into some business graphics and trending and drill down to details. But through all that, spreadsheets remained the pervasive BI delivery vehicle for a lot of reasons. Now we're getting into high business value through predictive analytics and data visualization, both those types of analytics require huge amounts of data, huge amounts of variety data, and they need to be able to be very responsive. That's driving more and more the need for that data on the volume, velocity, and variety. And then you get into other logistical things, as Fred mentioned about the iPhones that a lot of us have, and iPads, et cetera. People are mobile. People are trying to get operational analytics and data, and they're trying to do things on their own. So there's a whole lot of push to take that data and expand it in the enterprise. Now, the typical type of deployment, traditional BI, and this is where I think Fred was trying to address with his product suite, was that you end up buying a database, an ETL tool, a BI tool. Most companies actually have 8 or 9 of them. You get a whole lot of servers, you get a lot of disk space, and you spend an awful lot of money, a lot of time in configuring and getting those systems together. Then you look at the data source systems, you get the ETL, you build out a big enterprise data warehouse, and then I think this is the key thing when we're talking about the analytics. We start building massive amounts of data stores, those silos that Fred mentioned. Each of those tuned to specific types of analytics and specific types of business processes. We do that because that's the way the databases and the servers traditionally respond and work best. So an awful lot of attention is paid to that architecture. Finally, on the analytics side, we buy the BI tools. We get a variety of tools like OLAP, spreadsheets, dashboards, et cetera. And again, each of those requires specific data structures at this point in order to work. So then what happens, what the current state of sort of analytics and BI is today is sort of these 4 different quadrants. One, it seems to be very complex to folks. They really can't find that path of the maze as you see in the diagram. It's very complexing. There requires an awful lot of skills and a lot of time to design the architecture. You can know a lot of piece parts. What's resulted then is the time for business users to do analysis, to get analysis through support through their IT group or to get reports is this long, long queue. And so it's not just getting real-time data, it's just getting the ability to look at the data in the first place. And that's very slow because they have to build those different BI data stores and data marts and cubes in order to look at stuff. Certainly, everything's very expensive, and the complexity and the skill sets require a lot of cost. That's an inhibitor. And finally, as Fred mentioned about the data silos, the data silos in enterprises aren't really as organized as the ones you see in the picture, but each of those are stovepipes, usually set up to business processes and specific types of inquiries and take a long time to develop. So what's happened, sort of emerging technologies have tried to address the data variety, the complexity of the data analytics, and the skill shortfall. And I just listed some of the technologies. We've talked about a few of those today that are out there that are trying to address these problems. But one of the specific areas that I find very exciting and have a combination of the previous emerging technologies is really specifically on BI analytical appliances. There's a variety of them. They're not all created equal, but they have combinations of hardware and software, some proprietary, some commodity selections. But the key to the ones that are successful is that they've tried to look at the complex BI query structure that is needed to do analytics and try to shape the appliance either through hardware or software or combinations in order to get those queries to be answered and fast, also to avoid having to create all those different BI data silos. So you don't have to create all the OLAP all the OLAP cubes, data marts, et cetera. They're trying to lower the overall cost of the application itself. So the appliances themselves is very exciting. Like I said, I started off as a database engineer way back when, creating databases, not just using databases. And a lot of the things that Fred mentioned as far as vectors, compression, columnar, et cetera, are very exciting because what it's really doing is breaking down what the complex query usage patterns would be in BI and looking how to make it faster, more efficient, and more cost effective. And that's exactly what we're looking at. And that's just some slides on me. Eric?
Oops.
Rick. Go ahead. You can just start asking questions now.
Okay. All right. So, Fred, one of the things, as I mentioned in the slides, and I think you addressed a little bit, is sort of these different query patterns between transactional processing systems and BI analytics is one of the drivers for appliances and some of the approaches you're taking. Maybe you could talk a little bit about what the key differences are in these kind of query patterns and how you address them.
Yeah, sure. So, we have the benefit of having both the Ingress database and the Vectorwise database, which have shared technology. And so, when in a transactional or OLTP environment, typically what we're looking at from a query pattern is what I call a single lookup. So, for example, look at an airline reservation. I was flying last week, so they pull up Fred Gallagher's record, and it's just a one record that's being considered in that query. When we're looking at analytics, it's okay. Let's look at the characteristics of the business travelers across millions of records, and determine something in terms of socioeconomics or some way to sell or promote airline travel to those folks. So the distinction in the query patterns will be, many records analyzed at once in a analytical application. But whereas in OLTP, we're just typically looking at single lookup, and that's how those technologies were originally designed.
Okay, and I think one observation is I think DBAs and a lot of IT folks are geared toward the transactional patterns and tuning databases in that context.
Exactly, and so when you look at that, that is an area where companies spend a lot of time. It's sort of what I call a layer on the cake, is that tuning aspect that you're talking about, where there's a lot of and tuning is a good word to use for it. It almost reminds me of a car mechanic tuning up the car to perform better. That's an area that folks have become accustomed to, and when we're it's one of the areas that we sought to address when we introduced the Vectorwise technology. And again, we have so much performance headroom that we're able to minimize or almost eliminate a lot of that tuning. It's again, I use the car analogy. I don't there's a computer in my car today, whereas when I grew up, it was a Ford pickup that I could take apart and put back together. People don't want to do that these days.
That's a good analogy. Now, going along sort of with the query patterns, one of the things we talked about briefly was the fact that on the BI side, there's an awful lot of databases, OLAP cubes, flattened data sets.
Sure.
Oftentimes people do aggregated tables in order to get better performance when they do dashboards or scorecards. Sometimes they throw in operational data stores. So it's not just sort of your data warehouse. There's an awful lot of databases that are designed, tuned. They have those indexes that you mentioned. So how do you sort of go about eliminating them or reducing the need for those?
Sure. So a lot of, and let me make an assertion too, Rick, is that a lot of those innovations were deployed to address performance. So if you look at a view or a cube, it was not possible to query the data to generate that beforehand. And so you'll have folks that create views or pre-compute what we call SQL aggregates beforehand. And so what we've done with Vectorwise is we've actually, because of our query performance and our headroom, is we're able to compute aggregates on the fly. And there's a number of benefits to doing that. One of the clear benefit is that if and you also mentioned indexes as well, is whenever there's changes to the data, folks want to analyze the data, as it is, in the moment. And so if the aggregates were computed, a day ago or a week ago, well, they need to be updated with changes from, today or last week. And in that context, energy has to be put into the system to recompute those or to update them, and there's a lot of work that takes place with that. So with Vectorwise, because of our performance overhead, we don't have to pre-compute those. The work is done on the fly, and organizations don't have to spend time creating those structures, creating your views, or specifying indexes. And so it's really, and the really neat thing is that this vector processing it's been there, it's there on the chip, and it's been there for years. And so we're just providing that to the market.
Okay, now that sounds good. I agree with you. Each of those innovations at their time were set up to sort of improve performance. All of them ended up sort of not quite getting there, and so we sort of have each of these sort of silos in that sense.
Yeah, and you end up, to your point, is you end up starting to put a process around that innovation, right? You start having, somebody on the team is, addressing the views or the index, and you actually start providing human capital and human cost associated with that as well.
Right, and I've noticed when we start off a lot of times on the data architecture side and the integration side, and I'm always surprised at how many different data sets and tables and flattened structures that BI developers have snuck in there for performance, and they wonder why the reports have different numbers. It's like, well, forget about spreadsheets. People, each of your reports probably has their own data sets, flattened structures out there. So I think there's a hidden, which causes problems, right, business-wise, et cetera. So this addresses, your solution addresses that too, which I think is excellent. I think that's sort of one of the hidden costs. Spreadsheets get the bad names, but the reports are sometimes just as bad.
Exactly. You have to, whenever organizations are looking at it, I always coach them. You need to look at the process as opposed to just the technology, and I think you've hit that point, with your example really well right there.
Okay. Now the other thing is sort of, I know you mentioned, real time, and I think people get into that, but sort of time to market, meaning I had that picture, a little drawing of the person at the desk with a long queue of people waiting to get reports done.
Exactly.
So there's a whole process of figuring out what the data, the business needs are, getting the data, analyzing it, designing the queries for those data sets that we just talked about, then tuning the database, then setting up for each query. How do you, besides sort of the faster and better than sort of the OLAP or flattened data structures, what other kinds of things do you think you're able to address with this kind of solution in that scenario?
There's a really good, so we have a couple of things, but let me give you a story, and actually we've had two prospects. One's a customer now, and one's a POC that have implemented what we call rapid prototyping. And I thought of that when you had the picture of the long line. And what we look at, so one company is a retailer, and they have a number of regional distribution warehouses. And so they have these regions come to central IT and say, hey, we want to, we need to build a data warehouse for a big data project. Well, the time that it takes to determine feasibility, and feasibility both from a business perspective and from a technology perspective, is daunting. It's not just the time, but also the budget. So they were looking at probably 6 months and considerable budget to prove feasibility. All right, that's before we're seeing any benefit. And so the CIO is stepping back saying, okay, I have 5 regions asking for different data warehouse projects. How can I afford, we don't have budget just to get through feasibility. So what they've decided to use Vectorwise for is what we call rapid prototyping, which is to take the data set and quickly do a prototype that will generate results that determine whether or not the business results will be delivered. So that's the first order of business. Put aside the technical feasibility, because we want to know, if we implement this project, be able to deliver on the ROI if everything works. And the actual CIO, he thinks that 2/3 of the projects will not move forward past that. And then the second point is to prove technical feasibility. And so we're able to do that in weeks, which might take as much as 6 months, and much more budget in terms of being able to move a project forward. So that's the and if you don't have sort of a rapid prototyping capability, it becomes what I call more of a political process to decide which one of those projects are going to get funded. It becomes more of a advocating and sort of determining, okay, what do we think? What's our gut tell us? As opposed to, well, let's run a quick prototype and see if it delivers the benefits and if it's technically feasible.
Right. No, that's excellent. I think a lot of sort of agile and people trying to do rapid prototyping have been stalled just because of the tools and the techniques they use. So yeah, that sounds excellent.
And it's a great. I always, in business and in technology, it's always let's fail early, all right. And if you have there's some projects that will fail. Let's fail them as quick as we can.
Absolutely. I mean, the standard MO of any project is they go through the normal traditional life cycle, and then at the tail end, the BI developers are always surprised that the business has changed their mind or haven't told them everything. And if you can do it quick, it's not really failing, but it's like if there is a mistake or a gap or something they forgot, if you do it quick, it isn't a failure. It's the ability to adjust. Whereas if you wait 6 months and you have those same issues, and you will, you do fail. So
and what business doesn't change over 6 months? I mean,
what businesses change over a week sometimes?
Yeah.
But absolutely over six months. Now the other thing, and this is switch a little bit. The other thing that I always find with emerging technology, and I know some of the stuff that you have isn't like brand new. You've been developing it for a while and been implementing it with customers for a while, but let's just brand it as sort of emerging technology.
Sure.
There's always this sort of barrier. People always worry about do they have the skills for it? Is it going to be too expensive, et cetera? But how do you address sort of the the hurdle of the emerging, and we don't have the skills for it, or it's they sort of you get dazed looks when you start talking about vector processing.
Right. I mean, the great thing about this is with our customers, I don't have to talk about vector processing. We adhere strictly to standards, so we're adhere to the SQL standards, and it's actually a great benefit because we've had customers that have realized this is that Vectorwise, because we consume and we allow folks to query standard SQL, is very powerful to an organization. Because they don't require special skills in tuning or even special skills in writing a program. And even what the skills that are required is using a standard BI tool, of which there are many. And some of those BI tools, they generate SQL that if you were to look underneath it is really sort of extreme, or sometimes I even use the word disgusting because it's really long and has lots of clauses in it. We eat that up, and we're very good at that type of performance. So business users, and it's not that business users aren't, I wouldn't never say that they're not smart, but they might not be trained in writing specialized SQL. But you're going to have a standard business user using a standard BI tool start to query their data infrastructure and get answers back to key important questions in a very timely fashion. So that's really a key benefit that we have. We don't require that in-depth learning of a new programming format or language. It's standard SQL.
Mm-hmm. And like you said earlier, you've sort of taken out a lot of the tuning and performance issues, so you don't need that skill set.
Exactly.
Okay. Now I do have, we don't have too much time left, but I do have one question
Sure.
for you, and that's, there's a lot of hype. Anytime you have emerging technology and you're dealing with, big data hype, you got performance issues, appliances, or whatever. What happens is you have folks like yourself who have real solutions in the area. Then you have everybody jumping on the bandwagon and sort of jumping on appliances, jumping on columnar, jumping on whatever. So how do you get through the hype when you're talking with prospects and with customers, and sort of explain the differences? I don't mean trash any competitors, but sort of how do you get through the hype maze that sort of confuses people?
Sure. I think the key, for me is actually the sort of engaging with using the product, and engaging in a proof of concept, and customers taking their data and seeing the results on Vectorwise, and companies can't afford to do that with 10 vendors. We've constructed a product here that folks could in a day start to see very good results on their data with their queries, and having that sort of short period to get a taste for what we can deliver is one way to do that. from a product perspective. And the other way is just sort of proof points in the market in that the customers that we work with, we're very key in making our customers successful. And that sort of helps with other proof points in the market. So those are really the two things that we've done in terms of product and then proof points.
Okay, that sounds excellent. Now, Eric, do you have questions from the audience? Or?
Yeah, we do. We've got a few good questions from the audience. So let me just go ahead and chime right in here. I'll start. We'll do a first come, first serve kind of thing. So let's see. This is a very, very detailed question, and we love detailed questions, folks. So thank you for sending these out there. One of the attendees asks, how can you leverage this operation at the chip level and go through the operating system? I understand that Vectorwise runs on Windows. Does the OS allow you to access these very low-level hardware operations?
That is a really good question. So one of the things to the person that asked this, and we can go even greater if we want to engage with you individually, but what Vectorwise has done when we rewrote the query engine, we took in mind modern compilers. And so having an understanding of how a modern compiler works, we're able to compile against the chipset. So when we look at, yes, so the answer to your question is yes, we're able to get past the OS to take advantage of these capabilities on the chip. And to that end, we do support Linux and Windows, and we see pretty comparable performance on both.
Okay, good. Here's another detailed question. One of the attendees asks, how do you efficiently load data from slow external storage, such as disk? How does that affect overall performance?
Oh, good. So let me make an assumption here. So when we're loading Vectorwise, extracting from another transactional system, if the disks are slow on that transactional system, that's going to be the sort of bottleneck. If that's the question, we can't help on that extract side. On the loading side, though, we have provided for a very fast loader that allows us to write data to disk in an optimized format. So we have provided some innovations around that to speed up inserting or loading data into Vectorwise.
Okay, good. And here's another good one. One of the attendees wants to know, does Actian have the capabilities needed for a complex event processing or streaming analytics platform?
Okay, so right now as a standalone complex event processing or streaming capability, we don't provide that today. We have this capability which we'll be delivering in our action apps that we'll be delivering to the market later this year and into next year. So that's not a solution set that we provide today.
Okay, we always like when vendors will openly tell you what they don't do.
Okay.
There are some vendors who will say they do everything, and they'll just try to come up with some really creative way to shoehorn an answer that is not completely untrue. So we appreciate that.
Not completely untrue. Okay.
Okay, this is another very detailed question. It's a good one. One of the attendees asked, how flexible is your model for queries? For example, airline reservation requires a reservation code. So can your model support query by ticket holder name or flight ID?
All right. So our model. So right now we provide the database. So inside of our database engine, someone would create their own model. Many folks just take their standard operational model. What I mean by model is your data model. There's the logical and then the physical. So folks can just move the construct of physical tables from an airline, some set of airline data, move that over to Vectorwise, and we would query it very well. You wouldn't need to create a new data model or new physical tables to see very good performance on Vectorwise. You could. I mean, we work well with other, people call them schemas. We work well with, star schemas or other types of schemas. But you should see outstanding query performance on your, what I call operational transactional tables when moved over to Vectorwise.
Gotcha. Okay, good. And folks, if you arrived late, I'll just throw out a quick note here that we do archive all of these webcasts, and the archive is usually available, knock on wood, very, very shortly after the event, as in minutes after the event. So you can go to insideanalysis.com, look under the webcast section, you'll find it there. We are doing some updating on our site right now, so there's some weird code you'll see at the top, but it is still up there, and we'll archive all these things for later viewing. Another good question, one of the attendees asks, does Actian have a complete stack of software from firmware, OS, all the way to app? And can you kind of talk about, because there's some questions around the integration side, and you talked about Actian apps, which I think are very interesting. Can you just kind of flesh out the stack that you guys have?
Sure. So today with Vectorwise, where we spent most of the discussion, Vectorwise is not a stack. It's a database management system. And in addition to Vectorwise, as well as Ingress, which is another database management system, we have a category of apps called Action Apps that we're releasing later this year to the market. And that would be much more, Action Apps would in fact be a stack that we would offer, and we'd actually offer it as a service. So when you get into the details, your people would or end users would be consuming a service, not necessarily the software itself. And so those are sort of the two consumption models that we have. We don't typically get into firmware, as the question was asking, but we have a very we've written the Vectorwise database to take advantage of modern chips and compilers is really what we've done.
Okay, that makes sense. All right, and we got a few more good ones. Thank you so much, folks, for asking these questions. It makes my job much easier. We have a question about, is it just about a warehouse? It's my understanding it's not technically a warehouse product. That's one of the questions here. You know, is it a warehouse product, or is it used to store transaction data as well? Can you speak to that?
Well, let me make an assumption. I think what the question might be is Vectorwise a transactional database, or is it can it be used as a data warehouse product? So it is an analytics reporting or data warehouse product, and the Vectorwise product is not designed for OLTP. We have our Ingress database that is built for that, and there's just a wealth of the products that are common to each other, especially the external SQL interface and the connectors into the database. So there's just a wealth of commonality between the two products that are very useful to companies that are using Ingress today, or Vectorwise customers that might need a transactional database. So Ingress is for transactions, Vectorwise is for analytics.
Gotcha. Okay, good. And here's another good question. One of the attendees, actually one of our regulars, asks in notes, really, the following issue has been partly dealt with, but does the structure of SQL queries change from other configurations? In other words, what are the main differences, maybe in relation with vector processing, or is it just that the path and velocity will change?
Oh, wow. Let me just look at that. That's a long question. Let's see here.
That's a good one.
Does the structure of SQL queries change from other configurations? So what we see, go back to the point I was making about the skills that are required here. We really see the benefit is that folks don't have to hand-tune their SQL, all right? And that's where we have seen a really good pickup with customers. You can end up having a BI tool, or even somebody that's new to SQL write SQL, as long as it's adheres to, it has a acceptable outcome. We do very well with that. The tuning is the big difference that someone would see. It's standard SQL, folks. We have customers that will cut and paste their SQL from another database or BI tool into Vectorwise, load their data, and then see the results that we've been talking about today.
Okay, good. And we got about another minute left here. And folks, as you may know, I typically broadcast from right here in New Orleans, and our good friend Isaac is coming on shore as we speak here.
Oh, goodness.
It's coming. So if lightning strikes, you'll know, because suddenly we just won't be here. But we got about a minute left here. Rick, do you want to ask another question?
No, I think I'm good. I've been fascinated by Fred's responses.
And here's another good question that just came in. It's a very interesting one. One of the attendees asks, is there an interface between Ingress and Vectorwise so that analytics can happen in real time?
Oh, wow. So today, no. But it's an interesting use case. I've had a couple folks ask about that, but it is. And so what I'm assuming that the person is asking, if we have a transactional system, say your airline reservation system, and somebody wants to do analysis in real time against that. Today, we don't have that capability in the version of a product, but it's something that we've talked to a few customers about, and I'd be interested in talking about it more.
Here's another very specific question. Why do you not use GPUs for processing, e.g. Tesla?
Sure. So the GPUs are, while they're relatively standard, we're just using standard microprocessors used for computing perspective. The primary reason is that it would take additional work for us to port over to GPUs, and they're just not as widely used as standard Intel architecture x86 CPUs. Another interesting concept, and I think it would be, we'll see how the GPU market moves forward.
Yeah, right. Well, folks, we've burned through another hour and change here. Big thank you to our analysts of the day, Dr. Robin Bloor and, of course, Rick Sherman. As I've always mentioned, we do archive all these webcasts. You'll be able to find that at insideanalysis.com. We are dealing with a bit of an issue on our site right now, but it should be remedied fairly shortly. So, hey, thank you so much, ladies and gentlemen. We will have the archive up very shortly. And with that, we're going to end the event and bid you all farewell. Thanks to Actian for stepping into the briefing room and for Rick's time, and, of course, our very own Robin Bloor. So this does conclude our broadcast, folks, but we'll catch up to you next month when we dive into the whole topic of integration. And the EdCal is just out now. The editorial calendar for the briefing room in 2013 is out now. If you want to get a copy, just let me know. Send me an email. You should have my email. It's probably how you found this event. So let us know. We're always curious to know what you folks want out there. So thanks again, folks. Take care. Bye-bye.